Welcome to Erudition's PAT walkthrough videos. This is our first video on keyhole problems, and it's going to be an introduction on how these problems work and how generally to approach them. Be sure to continue on to our later videos on specific keyhole strategies that are also covered in this series. For keyhole problems, also known as aperture problems, you are shown an object on the left, and then you have to pick an aperture, or opening, that the object can pass through perfectly. But what does that mean exactly? First, it means the object must be able to fit through the aperture on a straight trajectory. The object can be rotated or turned in any direction before moving through the aperture, but it cannot be rotated and it cannot be turned in order to actually move through the aperture. Like, twisting and turning can't be one of the ways that you can kind of get it to fit. It needs to be sent on a straight trajectory all the way through the aperture. In these problems, the correct aperture must match the outline of the object perfectly from a certain direction. Notice that this aperture perfectly matches the outline of the object from this direction, so that would be the correct answer. Hypothetically, there are an infinite number of possible apertures for any given object, because you could move an object through an aperture from all kinds of slightly different directions. But the DAT is not that mean. And there are generally only 3 views of an object that you'll really need to evaluate in order to pick the right aperture. So let's see what those are. You'll notice that the objects are kind of sitting on an invisible surface, and there are 3 standard apertures that relate to this surface. The first is the top to bottom aperture, which would correspond to the outline of the object from this direction, straight down towards the object's base. There are 2 other apertures that they may ask for. One we call the front to back aperture, and it corresponds to the shape from this perspective. And the other one is perpendicular to the front to back aperture, which we call the side to side aperture, and it comes from this direction. So those are the 3 general apertures you'd want to picture for this object, and you'll want to try and visualize these before you begin evaluating the answer choices. You'll notice that each of the answer choices usually somewhat resemble one of the correct apertures. They'll just have 1 or 2 details slightly off about them. For example, they may have the wrong proportions, like choice A, shown here. Choice A is just a bit too wide compared to its height, so it doesn't quite match the object. Answer choices may just have the wrong overall shape, like choice B, which actually looks like some kind of combination of the front to back aperture and the side to side aperture. Or choice C, which shows some extra slanted edges on the sides. Or answers may show features correctly shaped, but in the wrong position on the aperture, like choice E, which shows the arms of this object sitting too close to the middle. Notice that the correct aperture is shown at the same scale and with the same proportions as the object itself, and in this case, it matches the shape of the object from the side-to-side perspective perfectly. Alright, let's look at a few example objects and talk about how to determine the basic shapes of objects and apertures in keyhole problems. The first thing you'll want to remember is that on keyhole problems, you assume no asymmetries or irregularities in areas that you cannot see. So for an object like this, if there's nothing sticking out on this side, then you can assume that the back edge goes straight down without any extra features. So to clarify, this is what the object would look like then if you made it transparent. However, if we saw an object like this, that appeared symmetrical from side to side, we could assume that this side is the same as the visible side. And this is how it looks if you turn it around. But this object that we're actually dealing with doesn't have any signs of edges or faces sticking out on the left side. So we can safely assume that that back edge goes straight down. And here's what it looks like when it's turned around. Let's talk about the basic shapes of the possible apertures. This object may look a little confusing at first because it's got a lot of different faces of varying sizes and shapes. But always remember that the aperture must be big enough to fit around the largest part of the object. And this will make it much easier to see what a possible aperture could be. For instance, if you're looking for the top to bottom aperture, you'll want to notice that the object is largest at its base. So the rest of the object is going to fit through an aperture that's shaped like the base. Likewise, the front to back aperture will be shaped like the biggest part of the object from that direction. And in this case, that's the back of the object. So the front to back aperture would be shaped like this. And lastly, from the side to side view, the object is more consistent throughout, but the side to side aperture will have to fit around this middle section, which also appears to be about the same outline as the far left of the object. Let's look at another example. Let's say we have an object that looks like this, with two different components connected by a bar in the center. One component being wider at the top and skinnier at the bottom, and one wider at the bottom and skinnier at the top. The front to back aperture will be pretty straightforward in this case, and looks something like this. But what about the top to bottom aperture? Well, this left component is biggest at the bottom, so that bottom face will determine the shape of the aperture on that side. And this right part of the object is bigger at the top, so that top face will determine the shape of the aperture on the right side. So you end up with an aperture that looks something like this, with these two separate boxy parts. This narrow part in between then corresponds to the bar that connects them, since there's a small gap between the two side components, where you can only see this bar running across. And what about the side-to-side aperture? This one's a little funky, because from the side-to-side view, this right part of the object is biggest up here, and the left part of the object is biggest down here. And since the aperture must accommodate both parts, the shape of the aperture is something like this, a sort of squat hourglass shape. Lastly, say you have an object with like a lot of different components sticking out in various places, like this. Let's start by looking at the top to bottom aperture, because this aperture would be mostly just the shape of this large block. But there is one other component that sticks out from this block in the back. So the aperture must also accommodate this component, which is the back of this large disc. Notice how this shape is rectangular in the top view. So that would be our top to bottom aperture. Next, let's analyze the side to side aperture. The aperture must accommodate the tallest or biggest part of the object in all places. So if the object were just a board with this one front bar, it would have an aperture like this. But the aperture must also accommodate this tallest piece that sits towards the middle of the object. And on the right side, from this perspective, this disc is the biggest, and therefore must also be accommodated by the aperture's shape. Notice, however, that this little half-moon shape does not affect the overall outline from the side-to-side perspective. And so, this would be the side-to-side aperture. For the front-to-back aperture, all of these components would appear rectangular, and you'd want to make sure you're properly assessing their heights and positions relative to one another. Notice that on this side of the aperture, you can tell that this disc sits a little bit further to the left than this tower, but not so much that there's an actual gap between them. The disc is also a little bit shorter, so that accounts for this staggered shape that's seen in the aperture. And once again, this little half-moon shape does not affect the aperture at all, because it's hidden behind the tower. Now that we've discussed how to analyze the basic shapes of apertures, let's talk about the fact that the DAT also likes to show apertures that are rotated and inverted compared to the position of the actual object shown. As we mentioned, apertures can be rotated and turned, since objects themselves can be rotated or turned before passing through the opening. But an aperture will still be a rotated or turned version of one of the three basic apertures we've already discussed. Let's explore this through this object, which looks kind of like a key. Choice A here looks exactly like the side-to-side aperture, and it's the closest to the orientation that's given on the object. So choice A would be correct. But what about the rest of these answers? Well, B and C look like the same aperture, just rotated in the plane of the page. These would also be considered correct apertures, since objects can be rotated in any direction before moving them through the aperture. And similarly, D shows the aperture inverted or flipped along this axis, compared to the way the object is shown. And E shows this inverted aperture rotated 90 degrees. So we already know that rotations are fine, but what about inversions? These mirror images you see on the DAT? Well, they're fine too. Why? Well, if you took the object and turned it around in this way, before you moved it through the aperture, this would result in the aperture looking like a mirror image of what we see from the front. So, since rotations and inversions are all okay, then any of these 5 answer choices would be correct apertures for this object. The last thing we want to go over in this video is the basic approach to keyhole problems. Let's look at this example problem from the ADA sample items, which we have full step-by-step explanations for on our website. The first thing you want to do when you look at an object like this is to get a sense of what those 3 standard apertures look like. The front to back outline for this object is generally rectangular, but there is a V-shaped indent at the top. So the aperture looks like this. The top to bottom outline is also largely rectangular, except it has an even deeper V-shaped cutout, so the aperture would look like this. And lastly, from the side-to-side view, the object would look sort of like this boot shape, so the aperture would look like this. And remember that the entire object should be able to slide through the aperture all the way. The second thing you want to do is look through the answer choices. And your first step would be to eliminate the answer choices that clearly don't match the shapes of any of these apertures. The ones that stand out to me the most as being incorrect include choice B, choice C, and choice E. B kind of looks like the side-to-side aperture, but it has this slanted top, whereas the object has a straight edge here. So choice B is incorrect. Choice C shows a V-shaped cutout, but the cutout comes to sharp points at the ends. The big cutout seen from the top view ends in edges that straighten out. They aren't pointed like that. So choice C is incorrect. And choice E shows two V-shaped cutouts, whereas in actuality, only one indent is visible in each position. This one's visible in the top view, and this one is visible in the front view. So choice E is also incorrect. After you eliminate the answer choices with more obvious issues, you have to look more closely at the proportions and positions of the aperture features. Let's look at choice A. Choice A looks pretty decently like the top to bottom aperture. It looks like the proportions of the height and width of the object match pretty well. However, look how far this V-shaped indent cuts into the object. It leaves only this tiny part below it in the aperture. If you look at the depth of this indent on the object and see how deep it is versus how far its point sits from the back of the object, you can see that it only cuts about halfway through. It goes nowhere near as deep. So choice A is also wrong. This leaves us with choice D, which resembles the side-to-side aperture. So one last thing to note about aperture problems is that it's easier to judge relative positions and proportions on these objects, like we just did, than it is to judge absolute ones. Like, you might think that the side-to-side shape on the object looks a little bit taller and narrower than it does in choice D. But a lot of times these absolute differences can have a lot more to do with the angle that the object is turned when it's presented to us in the problem. So let's look at the relative positions of things instead. For instance, if we look at the object, we can see its top edge is pretty close to 1/3 of the length of this bottom edge, just a little bit shorter, which it also is in choice D. And we can also see that this point sits about halfway between the top edge and the bottom edge, but maybe like a little closer to the top edge. And that's also consistent with choice D. So that's our answer. Now, just to show you how proportions can sometimes look a little skewed when the object is turned, let's look at the animation for this problem on our website. Notice how the angle of the object at rest really is deceiving when it comes to how tall and narrow the object looks to the naked eye. This is why it can be so helpful to focus on the relative positions of things. And we will talk even more about this in our next video, so be sure to check that out. Here's a summary of the keyhole basics. First, the goal of a keyhole problem is to pick an aperture, or opening, that the object fits through perfectly, if it moves on a straight trajectory. The aperture should be a perfect fit, meaning that it perfectly matches the outline of the object from a certain direction, and all of its relative proportions are the same. Generally, correct apertures will correspond to moving the object from front to back, top to bottom, or side to side. The outline of the correct apertures will match the overall outline of the object from these directions. Remember that the correct aperture must fit all parts of the object. So if it's a blocky object like this, the aperture would match the largest part of the object. If it's a multi-component object like this, the aperture will match the widest part of each component. And if it's a busy, complicated object like this, the aperture will get more complex, but it will be defined by the tallest or largest component in each area. Remember, correct answers might be rotated or inverted compared to the position of the object shown. This does not mean they're wrong. They just have to match the shape and proportions of a correct aperture. And here is a summary of the general approach to keyhole problems. First, you want to visualize the 3 standard apertures: the front to back aperture, the top to bottom aperture, and the side to side aperture. Second, you want to eliminate the answer choices that clearly do not match the overall shape of the object and its apertures. For the options remaining, you want to look closely at the proportions and positions of the features on the object. And remember that it's better to look at the relative positions of the different features instead of absolutes, like how tall the overall object is. In the next video, we'll be discussing the importance of relative positions and the proportions of parts of an object in keyhole problems, as well as the best strategies for doing this. So be sure to check out that video as well. Also be sure to carefully review our explanations, which show 3D models for each and every one of our keyhole problems. And they also guide you step by step through evaluating these problems. That's all for this video. Try some of these strategies out for yourself, and I'll see you in the next one.